Hello everyone. Let us now discuss how can we solve this problem. Count good numbers. So we are given with an n integer n. So what is our task is we need to return how many good integers or numbers we can form from it. So we have a string is good, or here a number is good if the digits 0 indexed at even indices are even and the digits at odd indices are prime. So they also gave us the numbers which are prime. So prime digits are 2, 3, 5, 7. Now, for example, 2, 5, 8, 2 is good because let us see at index 0 we have an even number, and at index 2 also we have an even number. Now at index 1 and also 3 we have prime numbers 5 and 2. 2 and 5 are always are prime digits, right? Now I have 3, 2, 4, 5. So at index 0 I am having an odd number. It is, I don't consider whether it is odd or prime, but at even index I need to have an even digit. But if it is not there, then it is not an good number. So given an integer n, return the total number of good digits strings of length n. Since the answer may be large, return it modulo 10 power 9 plus 7. A digit string is a string consisting of digits 0 through 9 that may contain leading 0. As they said, if I take 1, if I take 1, if n is equal to 1. They also said that we can also consider the numbers. So this is the blank that we need to fill. This is the digit that we need to fill. So 0. So at 0, which is an even index, so at even indices, I need even numbers. At even index, I need even numbers. And at odd indices, I need prime numbers. And we also know what are even numbers and what are prime numbers. But for clarity, let me write what are even numbers. Even numbers 0, 2, 4, and 8. Now, let us see what are prime numbers. Prime numbers are 2, 3, 5, and 7. So, sorry, I have missed 2, 4, 6, and then 8. So, these are even numbers and these are odd numbers. Sorry, prime numbers. So, these need to be placed at the odd indices, and these need to be placed at the odd indices, and these need to be placed at the even indices. Now, as they said, we can also place leading zeros. Now let us see how can we solve this. Here I can also place digits leading zeros. So if I place a 0, it is also a perfect number. So this is one string. This is one string, right? This is one string. If I consider all those numbers which are digits 0, 2, 4, 6, and 8. So totally how many good numbers we have? 5. So we return 5. But imagine you have n is equal to 5. Don't consider the example given in the question. N is equal to 5. Now it is simply an something like a permutation and combination question. So 1, 2, 3, 4, and 5. So we are said that at even indices we need an even digit, and at odd indices we need a prime digit. Now, what are the possibilities that I can place at this index, which is 0? So at index 0 and index 1, 2, 3, and then 4. Right. At index 0, it is an even index, so we can place 5 digits there. We can place 5 digits there. Now, you might say, how can we place 5 digits there? How can we say that 5 ways are there? because you have a 0 here. But as they mentioned in the question, a digit string is a string consisting of digits 0 through 9 that may contain leading zeros. So I can also place a 5 here. So 1 is odd index. At odd index we need to place prime, and we have only 4 prime numbers. So placing 4 here, and then at index 2, 5, and then 4, and then 5. So if you see, these two are repeating. But before that, let me tell you what is the answer is. 5 into 4 is 20. 20 for 2 times. 20 for 2 times, right? 20 into 20. So we are doing nothing but let me tell you what we are doing, how we can get the answer. 2 into 2 is 4, so 400 into 5. 5 fours are 20, so 2000 will be our answer. Now see that here, if you take even n is also is equal to 10, then we will be having this 5 into 4. But if you don't know what is a permutation, or you skipped some lectures of permutations and combinations, let me tell you that you have 0 and 1. So as I said, you can place, so I am saying that at index of even indices, you can place 2 comma 4, right? At odd indices like 1, you can place 1 comma 3. Now just simply write that what are the possible combinations that you can get by your mind. Don't repeat it again. So at index 0 you can get 2, and then you can place 1, 2, 3, right? And then you can take 4. So from 4, 4, 1, and 4, 3. So how many possible outcomes we can get? Totally 4. It is simply nothing but number of possibilities or ways, number of digits that we can place at index 0, number of digits that we can place at index 1. 0 at index 0, number of ways that we can place at index 0, into number of place that we can place at index 1. This forms for every index. So that's how you solve this problem. But the thing is, 5 into 4 is 20, and you are having n is equal to 5. You need to take something like 5 by 2 will give you 2. So I am doing 20 power 2. As it is an odd number and percentile 2 is equal to 1, I am doing into 5. Now I'll write the algorithm, then I'll tell you how we can uh, get the power of 20. Now algorithm is something like taking indices at index 0 and index 1. So we are just taking, if something like b, a power b, we need to take a power b, and a is already is equal to 20 and b is something like n by 2. Now we'll be having this in result, or let me simply tell it as result. Now if n is odd, how can we check that? N percentile 2 is equal to 1, then result into into is equal to 5. So as I said previously, if n is odd, then there will be 1 5 remaining at the end. So we need to multiply our answer with 5. So here comes the question, how we can compute power. Now let us say we have 20 power 11 and 20 power 4, right? How can you write this 20 power 11? I can write this 20 power 11 as 20 power 5 into 20 power 5 into 20, right? Now, why 20 again? Because a power b into, let me say that a power m into a power n will be a power m plus n. So we need 11, so we just multiply it by 120 again. Now we have 20 power 5. How can we write this 20 power 5? I can write this 20 power 5 as 20 power 2 into 20 power 2 into 20. Now, how can I write this 20 power 2? I can write this 20 power 2 as 20 into 20. 20 power 1 into 20 power 1 if you observe carefully. Now 20 power 1 is written as, I am writing only the half. 20 power 5, 20 power 2 and 20 power 1 is written as 20 into 1. I simply copy this and paste it over here. Now 20 power 4 is also computed as 20 power 2 into 20 power 2, and 20 power 2 can be written as 20 into 20, and 20 power 1 is written as 20 into 1. That's it. Now the question is, if 11 is odd, when it is odd, we are computing 20 power half into 20 power half into 20. So if it is odd, right? So a power b. If b is odd, then we need to do something. We need something like half is a power b by 2. B is odd, then half is equal to a power b by 2. But before that, let me just write this half previously, and then if b is odd, half into half into a. This will be our result. If not, the result will be half into half. That's it. This is the whole algorithm for a power b. Now how can I compute this a power b? This is the same recursive function, a power b, right? If I write this as a power b and write take int a and int b, this will come as a function, right? So this is how we solve this problem. And if you like this video, do share to your friends, and I have given the code link in the description. Go and check it. And if you like this video, do share to your friends and do subscribe. Thank you.